Welcome to Lebanon High School, and I'm Mr. Ernest, and welcome to the classroom that we like to call the SWELL classroom, the Smart Worldwide Effective Learning Lab. It goes hand in hand with my philosophy that we should use global connectivity through progressive technology in order to help facilitate learning with our students. You happen to be today in one of my Advanced Life Science Plant and Soils class. This is a dual credit course through Purdue University. Here at Lebanon, we teach all three dual credit courses that Purdue has through the College of Agriculture in animals, plants and soils, and foods. In this particular class today, you're going to get to see three different groups that are going to show you how they have used project, problem-based, or inquiry-based learning in order to further their knowledge on a particular subject. One group is going to be working with tropisms. The other group that you will see will work with hormone growth in plants, and also another group will be showing you some new technology that they're using with the iPad after having done the by hand old way of chemistry that took them several weeks to complete. They're going to show you how to do it in a matter of moments. So with that, I'm going to turn it over to the students to show you how they work through facilitating their learning.
I'm Nick Fruits. I'm Tyler.
I'm Lucas.
And we're doing a study on hormones in our plants and soils class. And one of the hormones we use is gibberellic acid, and it promotes stem elongation and growth. And we just did a study with the corn plant on how well it worked. And this is a control, and this is the one corn plant with gibberellic acid. And you can see that the stems were a lot longer and it grew a lot quicker from the beginning.
We had a second experiment using different seeds, and these seeds were germinated with the gibberellic acid, which they were just put into a powder. But it is mostly used in like grapes and like to create bigger grapes and bigger bundles and stuff. But in this situation, as you can see, if you look at the normal one and the one coated with gibberellic, the normal one hasn't even sprouted yet, but the one with gibberellic has. So it is increasing the speed at which it grows.
And higher concentrations of the gibberellic acid actually create the opposite effect and can kill it or even slow it down. And normally the amount used is 0.01 grams per liter to 1 gram per liter, and it just all depends on what plant you're using and how many seeds you're trying to germinate with gibberellic acid.
We're doing a project on tropisms. As Mr. Ernest said before, we are working on just kind of seeing how the tropisms work actually by doing it in person. The plant we're using is a morning glory, and just let's talk a little bit about tropisms.
Well, basically what a tropism is how a plant responds to a type of stimulus. And what we tested with this morning glory plant is how it responds to touch and winding. And you can see that up all the way through this rod that we placed in here and then the pole.
Hi, I'm Joe, and this is a plant cam that we use to take the video and pictures that we used to show the tropisms. This is a time-lapse camera, and it can be programmed to take pictures anywhere from 30 seconds to 12 hours. And you can also insert an SD card into it to have more memory. For our project, we programmed the camera to take pictures every 30 minutes.
And I'm Grant, and in a minute we will see how we can get the pictures from here, upload it onto our apples, and make a movie showing the growth on iMovie.
Okay, now we have the plant cam in the classroom. We are going to hook it up to our MacBooks. We have a class set of MacBooks that we use. All we have to do is just plug in the two USB ports. and then it will pop up. It's a file. So to scroll down, and we've already saved it as a video. You just have to drag that into our iMovie. Let the iMovie convert it. And then after we convert it, all we have to do is put the new clip onto the video. Just like that. And then it's ready to go.
As you can see, the Morning Glory plant used stigmatropism to climb around the pole and the dowel rod.
Thanks for spending time with us in our plants and soils classes at Lebanon High School.
I'm Hannah, and in my plant and soil class, we've been working on soil testing this year. We spent about 4 weeks in class taking our samples that we actually went out and gathered and testing all the different parts, such as like phosphorus and carbon. But we actually discovered a new technology using the iPad and a Pasco Passport sensor to actually test without the hand. So this is a new technology, and we've been able to do it very efficiently throughout this.
Carbon is important to our world because it's one of the main things, the main elements in growing things. And through carbon, it's released into the air from soil, taken in by plants, and when those plants die, the carbon is again released. It's a never-ending cycle. When we tested by hand, it took us 4 weeks, and there were a lot of variabilities that came in. And so with the Pasco sensor, we didn't have any of those variables that would affect our tests.
Carbon dioxide in these containers, and how that relates to this carbon that we're testing for is that living things emit carbon dioxide. So here we go with our first test.
You insert the tester up to the rubber stopper and press play on the iPad.
And as you can see, it's already starting to read the levels of carbon dioxide in the first container, and it's fairly high levels. So we're going to let this go for 30 seconds here.
The difference between 3 bottles is the level of biodegradable material. This bottle doesn't have nearly as much actual living organic matter in it, so the test should show lower levels.
And that would be our first test. Now we're moving on to the second one. And this one is dipping down a bit, so it's a lot less than this first in the amount of carbon dioxide in parts per million. So it's reading this one. Still going down. It was a very efficient type app here. You can use the iPad or you can use a smartphone, like the Droid, for example. So this is very easily adaptable. This is our third test. This one's considerably lower than both of them. And as far, again, as I mentioned, out in the field, you can actually take notes on this app using SparkView. You can also easily view your results and actually send them back to the lab as well. So this can then be viewed in almost a speedometer type view right here. You can view each of them, easy access, as well as we can email them. So this is our new technology using the Airlinks Pathgo Passport carbon dioxide tester and an iPad.
Well, I hope you've seen from the time you've spent with the students how they're able to use their projects and their inquiry-based learning in order to deepen the learning that they've done and make it much, much richer with their experiences in doing projects that they are actually in control of and doing. And one little sideline that comes out of this that I'd like to show with this group of Hannah and Abby, one thing that we have in the agriculture world is FFA, which is an intercurricular organization that goes right hand in hand with the curriculum that we teach in the classrooms. And Abby and Hannah actually took the research that they did in class and made it into a demonstration and research project through the FFA and actually won a contest in our district, and they will actually be going on to state contest later on this year. So with that, we're glad that you were able to spend time with us today, again, to learn how using student-based management, letting them actually do the learning and learn to learn has been important in our particular world here at Lebanon High School. Thanks again.